from the get-go. Oh, we're live. Hello, everyone. It seems we were busy chatting, and I forgot that we were actually broadcasting. So welcome to this episode of The Edge of Things on this fantastic day of June. Now, today it's a bit different from the usual. In the past, we've had panels and things like that. And today I'm questioning Kilton. No, this is rather, it was presented as me, the moderator, and Kilton, the guest, so to speak. But really, this is more of a conversation, right? So we had the opportunity recently to work on an interesting project together, and we learned and shared knowledge about specific things around edge security, and thought it would be a good idea to put this in a conversation format. So Kilton, maybe we can start with that. I mean, we are in the Edge of Things webinar, but there is another Edge of Things that we introduced recently, and so maybe we can start with that, explaining what that is.
Sure. So one of the things that we've seen in the edge computing industry, I guess you could call it, over the last years is that there are really two different types of people seeking information. The first type is those who come from the background, people who are deep into embedded computing or have been spending time in the last decade with IoT. And those folks have enough background knowledge to assess the merits of very detailed posts. And the unfortunate thing is that there's not that many people in that category. And then the other side is the vast majority of folks out there, people who do not have enough of this background to be able to fill in the gaps when someone is talking about a particular topic in edge computing. They don't have this background knowledge. And seeing that the second type is grossly underserved, we thought, well, one of the things we do at the Eclipse Edge Native Working Group is thought leadership. In fact, it's one of the primary components in our charter. We said, if we're going to be producing information that enables others to enter the edge computing space, we're going to need to cater to this group more than the insider group, the people who could read a paper on a particular topic, right, and fill in that background. We need to provide more background. And this is, I think edge computing is in an advanced enough state that it's now possible to say, if we lay it all out, what are the different areas that someone should learn about or understand if they're going to take on edge computing. And then we asked ourselves, what would be a way to deliver that content that is not so heavy-handed that someone feels like they need to enroll in a year-long course or read the type of papers that are even too big to print out that that you take 6 months to work through? What would be something that'd be more digestible? And so the answer to this is short read articles that can come from a variety of sources, but all of them are able to be understood by someone just familiar with computing or technology in general. So in other words, there's 1,000 entry points to understanding edge computing now, and hopefully coming from an area where you're like, oh, I know that already, so this is an extension of that. Oh, okay, great. This resulted then in a publication on medium.com called Edge of Things, which allows us to be putting out material that is easy to get into and should lead you toward the next things that you want to understand. It's just begun. We've just started, and there's some posts in there already. And it's intended to fill in this gap and bring thought leadership to the level of where just about anybody could dive in and get started. And it's also intended to be a central place to learn all things and get up to date on all things, as opposed to needing to find the specific websites for this protocol working group and this security focus working group. It all funnels down to here. And then from there, you can discover what you need to know.
Indeed, and this is initiative, at least initially, that we have in the Eclipse IoT Edge Native and Sparkplug communities coming together, and eventually maybe we'll get posts from even further away, software-defined vehicle or the upcoming AI lab that we'll have and things like that. Anyway, I mean, lots of potential there, but let's stay focused for the time being on what exists. And by the way, in the audience, I forgot to mention that, but if you have any questions, reactions, or comments throughout this conversation, please use the Ask a Question feature of Crowdcast, and I would try to keep an eye on that and integrate that in our conversation to answer any questions that you may have. All right. So, okay, the edge of things, the concept being that, thought leadership, easy to digest and all of that. And to start the process, we decided collectively, when I say we, this is the Edge Native community in our community meetings, we decided to tackle security as a first broad topic. Why did we did that, Kilton, and how, why explicitly security is so important to edge computing?
So if you look at the way that cloud computing has grown, the interest of the last 5-6 years, a heavy interest, has been around being able to orchestrate and administer what you're doing in the cloud in a way that's predictable, programmable, automated. And the same thing has to happen for the edge, but instead of having all of your resources locked up in a data center with great degrees of physical security and network security and so on, the edge, by its nature, is fully distributed and probably includes locations that are not under your physical control. That would be really sad if you could only deploy your edge AI application to locations that real estate that you own. It would be very few customers would fall into that bucket. So you're probably going to put devices at a customer location or on a vehicle which moves around. Since that is the conditions under which the edge computing operates, you then can never reach the state of being able to orchestrate and automate and use things like infrastructure as code as a paradigm, unless you can trust that those devices are still the same devices that you deployed in the same condition that you deployed them in. So in other words, you need to have some layers of trust that you do have rolled into the cloud computing, but you have all of these protections that prevent you from needing to focus on this at day one. You can roll on all kinds of automated structures with cloud servers, and you have a level of trust that's already built in. Very different if you're going to put a compute-enabled camera at a customer site. And so right at the very beginning, we have to look at the foundation of trust in computing in order to get this right. And I think this is great because many of the layers of security that we now have on the World Wide Web and in cloud computing came after the infrastructure, the functional infrastructure was laid down. Think of how long it took us to have HTTPS be the required protocol or even the recommended protocol for a variety of websites. And this was a layer that was placed on top of an already functioning web. For edge computing, because we immediately hit up against the challenges of trust in computing, we get a chance to do this right and do it at the start. So that's why I think beginning with security is so important, is we don't have the opportunity to get it wrong and patch it later. And I don't think anyone wants to deploy $2 million worth of devices only to find that after 5 years, they need to go back to those devices in the field, collect them, and do some kind of a certification and security update manually. So you have to lay this down before you start, or it ain't gonna work.
Indeed, indeed, and in a way, that's the point of the very first sentence in this series of posts that we wrote. Scaling IoT and edge solutions without security is just scaling your problems.
Mm-hmm. Yeah, absolutely.
I would say that. So it's a dangerous road, and with edge computing, we deploy devices in the wild, all over the place. And there are various ways and various techniques that we can use as solution designers, developers, whatever our role is, in order to secure that. Now, one potential thing or potential way to do this that we felt as a group in our edge native community was worthwhile of our attention is something that we call device attestation. What do we mean by device attestation specifically?
Yeah, so of the different layers, we begin with the layer that allows the hardware itself to say, this is who I am, this is the raw condition that I'm in, and so on. And it's like the device is reporting everything that it knows about itself. And that can be then used to say on the receiving side of the information, okay, I either believe that you are in your original condition or you are compliant with what we would expect. And so the device is in essence attesting that it is a certain way. And if it's all set up properly, the way that the device is attesting can be trusted. And that's why the way that it's structured is so important. And then from there, you can say, well, if the very bottom layer, which is the hardware on which all of our edge compute is running, is trustworthy and attests properly, then we can begin to build from there. And so device attestation really is about the hardware and the thing on which the edge compute is running, starting off this stack of trustability.
Yes, and so in one way, it's about establishing the specific identity of a specific device, and then confirming on the other end that this device is trustworthy, so you can trust, well, whatever it will send back to the cloud or in your enterprise applications. And one important aspect there is also the ownership of the device, in the sense that, well, initially, if you are deploying a device, you will procure it from some sort of supplier, typically, unless you build your own. But that's, well, I suppose in this particular crowd, that's not necessarily always the case. Although you did it with your Darcy cams and all of that.
Yeah, there wasn't anything equivalent out there. So, nobody should build anything that already exists and can be purchased for a fair price. Yeah, exactly.
Yeah, so when we do the inventory, whether you build your own or you buy, essentially there are a few pieces of information to take into account, to track, in order to have proper attestation, which is the origin of the device itself, the current owner. So if you buy off the shelf, then you would be, let's say, the current owner, but it comes from a specific manufacturer. And then some sort of data set reflecting the state of the device, and we will discuss in greater detail what that data set could be, and then a set of certificates or signature that will ensure that all of that is trustworthy in some way. Now, there are various ways to implement that, and we came in the second post that we published with a sort of potential blueprint in order to implement this, and one component was to find ways for to manage the certificates and all of that, and then there is also a hardware component to it. So let me bring the diagram that we published in the second post on screen, and if yes, thank you very much. So it's much bigger now. Okay, so seeing this, what are the moving pieces, and what would be at a high level the process that we are dealing with there, Kilton?
Yeah, so one of the most important things is that you need on the compute board a component called the hardware root of trust. And the reason it's called the root of trust is that everything has to start somewhere. There's some mechanism for establishing trust on which everything else is based. And that thing, that root of trust, needs to have inherent to how it operates. It needs to have some mechanisms that allow you to be able to certify it and then rely upon it going forward. And let's talk for a moment about how that needs to operate. It comes down to hardware, because in the end, if everything is software, then it's running on something. And so even if you have a really great security layers in your software stack, you still have to have some assurance that the silicon on which it's operating is not in itself compromised. And so the hardware root of trust, there's a couple of different ways that you can implement it, but it has to have these key components. You have to have some way of storing some special information. The most basic information is an identity. You mentioned that you've got a unique ID. Well, think of like your vehicle identification number. So every automobile is issued a VIN. And if you want to take ownership of a vehicle, you might have a license plate that is used for identification, but that can change. But the vehicle identification number cannot change, as it's embedded into the vehicle itself, and is not something that you can get access to, because it's right in an area where you can only see it but not change it without damaging the vehicle. This makes sense. Well, the hardware root of trust has to have this capability, some unique identifier that can be stored. And then you need to have some secure space for storing information that's used in the process. And this, I'm just trying to generalize the concept here. So the implementation details are exactly why you should come read these sequence of articles. Smarter people than me have laid out exactly how it begins to flow and operate. But so you have the unique identifier, and then you have some space that you can trust. And that's because at one point you need to do some certification during manufacturing, right? And give some something like a private signing key that will be used to verify or do the attestation, right? This is who I am, and so on. And the reason that you have to have a special space for that is that on the hardware, you need to have implemented some ability to detect that somebody might be trying to make changes without your permission. And so if you can imagine the difference between your personal laptop or your phone, which is always in your pocket, and something like your Wi-Fi router, which you don't carry in your pocket every day, and you probably haven't looked at since you set it up and got your family Wi-Fi running. So you set up the home Wi-Fi router, and you do it when you move into your place, so you get new service, and then you don't really think about it very much. If I ask you, and everyone in the audience, when was the last, can you tell me every person who has touched that Wi-Fi router? That includes every guest who's been into your home. Maybe you've had some cleaning services come by. Maybe you have children and they have friends who have come over. Can you say for certain the list of people who have touched that box? Probably not. But you probably could tell me everyone who has touched your laptop or your phone in the last week, when you just think about it for a moment. Have I handed it to anyone? Because we don't physically protect all of the devices that will be used in our edge computing and IoT focused solutions, we need some way to say, I don't have to watch it every hour of every day or every minute of every day. I have some mechanism for saying whether or not anyone has been doing bad things to it. And that's why the hardware root of trust needs to be baked into the compute hardware itself. Is there's mechanisms such as perimeter defense, which can tell you the case of the unit has been opened. And there's other mechanisms as well for defending. But the idea is that you have some privileged information stored within, and you're not supposed to have access to it unless you have the authority. But maybe somebody can work around that by attaching some wires and so on. Well, in that case, if somebody tries to get physically toward it, we should probably clear it out or lock it up in some way, preventing it from being a part of the whole solution. So in other words, the attestation breaks down when that device can no longer say, I've been watching myself and nobody has been doing nasty things. When you can no longer say that, then that says, okay, great, I didn't have to keep you in my pocket, but I have essentially the same result. So that's that start of the diagram there, the hardware root of trust, and why it has to be hardware in the end. There has to be something in the hardware.
Yes, and in that second post, we explain a bit in greater detail how possibly you can implement that hardware root of trust. The main or the most popular way to do that right now is by deploying or using in the device something called a Trusted Platform Module, or TPM. Mm-hmm. A TPM would be like a self-contained computer that can securely manipulate secrets. Can we describe it a bit like that?
Yeah, exactly. You can, once you begin communicating with it, it has all of the right pockets and the right triggers and things on it that allow you to say, if we've begun communicating and while you're in a pristine state, I can then know going forward whether you remain in a pristine state, just by the way that the silicon is designed and the way that it integrates into the computer.
Indeed. And sometimes that will be part, let's say, of the CPU that you're buying. In most desktop computers, it ships that way as a kind of little secure enclave inside. But in most IoT devices, or even lower powered edge nodes, this is something more often than not that you will procure separately and integrate to the rest of the board, right?
That's right. Yeah, there's a number of manufacturers of these types of chips, and they tend to have capabilities beyond just being able to present an identity and store some special information. But the details of the features don't matter as much as just the understanding here. There are a variety of manufacturers. Some of them have made incredible progress over the last couple of decades to provide additional security mechanisms and intrusion detection mechanisms, really interesting stuff. But for those who make motherboards and full computers, yes, this is kind of a standard approach that they're familiar with. But for those who then venture out to make wearables and edge compute devices or things like a smart camera, this might be a new space and it might require new understanding. Hence the creation of the sequence of articles, because even if you need to engage an expert who has done this before, if you weren't even aware of the need for this and the rough outline of the steps involved, you may never go forward with adding a hardware root of trust. And that's the biggest mistake of all. Once you are aware of it, you can begin to understand what you don't know, but just having the base awareness is one of the problems in the space of IoT and edge. A lot of things have gone out the door without a hardware root of trust, just either because of lack of knowledge or for efficiency's sake, which, as we've stated, a scaled set of problems is actually worse than a centralized set of problems, and a distributed set of problems is worse than a centralized set of problems, right? So anyhow, yes.
Indeed. So when we say root of trust, it's literally the root component of this whole chain that we're trying to build, or at least in the posts we are saying a good way to provide device attestation is to build this chain of trust that validate various aspects of a device. So before we get in the more bit technical details there and focus on that diagram in the third post where we show exactly the various things, what theoretically could you secure in such a device when you design it? What are those things that you want to prove the trustworthiness of?
Yeah, well, so one is the unique identity, but we have an opportunity based on that identity to also add information about the origin of the components, or I should say certification at various steps of manufacturing and then deployment. This is very interesting in the world we're living in right now. There are supply chain issues across a variety of goods, and electronics has been impacted, and the tail end of this first pandemic wave, in a way that we thought at first we could handle and predict, and then we're realizing, oh, there are now issues that are downstream. This would be a strong incentive in these conditions. It's a strong incentive to provide falsified or alternatively sourced components, some of which may not be to spec or under the same levels of quality control. Regardless what entity is doing the manufacturing, you can add supply chain certification to the manufacture of a device by having the hardware root of trust and adding information and supply chain certification as you go. Well, the importance here is that this allows you to say at these different stages, calibration has been performed, or the required or requested levels of testing have been performed, or simply this was made where we said it was made, and the certification is then embedded into the product. And this allows you then to trust the things outside of just that root identity, and that might be some trust that you want around maybe the Wi-Fi module that got included in the board, or the cellular radio, or maybe a set of sensors that you wanted to know were integrated properly and calibrated properly before you begin using that edge device as an instrument of measurement. So every step that you take in producing the final unit is a potential point for doing some certification. And that level of trust then will result in stuff that comes upstream from there. But I'll pause there if you have anything to add to that part.
Yeah, I would say certainly we heard in the past about network switches that had been manipulated by some governments, in the shipping process to add, little spies in there to simplify things. And even there's a whole gray market where some untrustworthy individuals will buy some equipment and then modify the firmware to make you think this is the high-end model when it's the low-end one, and things like that. So you can avoid situations like that when you have a trustworthy chain of certificates and signatures that really certify, let's say, the path that your device took throughout the supply chain.
Yes, that's right. And, in a way, that is, without that foundational layer, you will always have the question, what are the sources of data coming in through a microphone or a temperature sensor or through a USB port? Because there's no way to really know unless there's some point in the process where you have trust in the entity, such as those who are manufacturing your circuit board, and a way to then say, well, when they last laid hands on it, it was this, and I have some way of proving that is still the case. So this is a really important point. Unless you design a circuit board that observes itself, which is a very difficult thing to do, the best that you can do in the state of the art is to have an entity that you do trust, such as your contract manufacturer, have that entity do its job and somehow embed that information or the signature of their process into the device, and then have mechanisms for knowing whether anybody has been capable of making an alteration from there on out. And if they've done it without authorization, breaking apart that signature. So let's be completely clear. A circuit board that says, oh, you're putting your finger on my CPU, so I'm going to just say, ouch, you are maybe doing it. That type of a circuit board is perhaps not even possible, because every mechanism that you implement to observe can be itself manipulated. So similar to concepts around blockchain and Web3 and emerging trustless environments, we have then a paradigm of signing and attesting that things have not changed to the best of our knowledge. And that means that it's really a gradation of trust as opposed to a perfectly trustworthy environment. So just an understanding of what this trust is and what it means. It does not mean that you have a circuit board that is guaranteed to have no spy chips in it, but rather that the last person to certify, or the last entity to certify, is where your trust should lie, and that things have not changed since then, as long as the circuit and the device have been set up properly.
Yes, which is probably at least better than the alternative of having nothing there.
I mean, in a world where this is the state of the art, this is what you need to be doing. And,
so in a supply chain perspective, it makes sense. But then as I build and deploy my own IoT solutions inside my organization, there are many things that maybe I want to monitor or certify on my own, so to say, to ensure that whatever data comes out of the sensors and edge nodes that I have is trustworthy, right? So what can we imagine there? Because there are so many possibilities.
Yeah. So now that you can trust the device itself, and you mentioned ownership, and let's talk about that for just a moment. When you've purchased that device from the supplier, since we have now the concept of something like a vehicle identification number, right, a unique ID, and then we have certifications built on top of it, it's also possible to, in a way, register your transfer of ownership. And so that also means that you could attach information such as to which customer you have deployed the unit. So you've acquired 1,000 edge cameras, and then as you did, you took ownership, and then you deployed 10 to all of these different customers, and each of them then is registered as the current entity that possesses the camera, even though you are the root owner, or maybe you sold it to them and you transfer ownership. This is all interesting stuff. Built on top of that, now you enter into the space of being able to do attestation of everything that flows from the unit and through the unit. This is where it gets really exciting, because if I can trust the unit and the unit has a GPS chip in it, then I can begin to do things like trust the actual location of that device. And when you think about it, I want to use the location for a variety of things, which we can talk about here in a moment. But if I can't prove that that location information is actually valid coming from hardware that I trust, then I might as well just have an open REST API and say, send me some geo coordinates, and I'll just go from there, because with no authentication required, because that's about how good your reporting of location is from a device that you can't trust. So if you can trust it, then you say, okay, the data I'm getting is trustworthy. Okay, great. Well, what would we do with that? Right off the top of my head, if I'm going to deploy some software to run at a customer site, and I have an edge camera that leaves the customer site, I'm pretty sure I want to stop running the software that's supposed to apply to that customer site. Might contain some employee information about letting employees check into that job site. Well, if the camera has now gone home with one of them in their work bag, I'm pretty sure I want to stop running that software.
Yeah, and even wipe the device, or at least wipe the personal data that could be in it and things like that.
Absolutely. You can use the hardware root of trust often to do things like hardware accelerated encryption of all of the data, so that there is no data at rest on the device that is immediately accessible. You need to have some ability to decrypt. And so if all data at rest is encrypted, and the only way to decrypt it is to have the root of trust and the trust chain intact, then everything is immediately wiped as soon as you repeal the ability to decrypt. So in other words, remove the decryption capability or lock it up, such as when the device is opened from, you take the screws out and you open it up and you say, okay, well, whatever was in here is currently inaccessible and will be forever, right? Because the device has been compromised. Great. That would be a wonderful thing to do as soon as you hit some kind of a trigger, such as the device going outside of a jurisdiction. And this could be across political boundaries or government boundaries or regulatory boundaries. Imagine that you cross over from one geography in which the data flow is allowed into a geography in which that data flow is not allowed, such as you have the right to be doing mining and mineral accumulation and refinement from one jurisdiction, and then when transporting the all of the stuff in a vehicle, you no longer have the right to transmit that information the same way. When you cross the geographies, you can just stop transmitting in that jurisdiction and then transmit again when you cross back over into the region where you're allowed to do so. It might even involve wireless signal itself. So not even the data, but the fact that maybe when you're in a certain geography, you are not allowed to transmit over a certain frequency. And so you just have to stop. And I don't think anyone wants to be sitting behind a computer terminal watching devices on a map and clicking start and stop and start and stop. This is the sort of thing that should be attested and then automated. The same way that in the cloud, we automate scale when there's more visitors to a website or a web app, we can deploy more resources to handle the greater workload. That's the promise of the fluid cloud. You would want the edge to behave similar, except it's rarely about the scale of a single node, right? Usually a node does its job and it's related to its purpose, and you don't need 100 more of them because there's only one vehicle that needs that. Here, the orchestration based on the attestation is more around protections or capabilities, right? Is this the device that should be running this workload? Because maybe it's the one that's pulled into the warehouse parking lot. I now want to turn on this application. And so that type of automation is only possible if you can trust the source.
Indeed. And then good luck if you want to do it the manual way with the worker shortage right now.
Mm-hmm.
You won't find anyone to click start and stuff all the time.
Yeah, it's not a fun job either. Oh, there, let me deploy there because they've entered the work site. You know, that's not using somebody's best talents.
Excellent. As we continue this conversation, I would remind the audience, please use the Ask a Question feature to react to what we are saying or ask specific questions or what we are covering. So please feel free to do that. And if not, we'll just continue. We can go at this for hours and hours. We spent so much time working on these posts. So we talked a lot about those possible use cases. Now I will share the diagram from the third post, where really we see at the technical level how we can achieve this and establish this chain of trust, so to speak. So we still see our TPM in the device coming from the TPM vendor. And we see a piece of information, this EK thing that is on the TPM vendor side and goes to our contract manufacturer and migrates in the whole chain. So maybe we can start by explaining what that is specifically, and then the other components in the flow.
Sure. So what you get from looking at this diagram is you can see that we build things as we go from left to right. And the main thing that you should remember about this is that starting from the hardware root of trust, you can now produce a chain of identities that are provided by the different really, it's the different players in the system that are able to do some certification and add some additional information as you go. And so we have a root identifier, and then we have built on top of it device identifiers and eventually here then identifier related to a customer and so on. And you can see at the top, we have a device enrollment platform. And then on the right-hand side, we have an onboarding target, which would be where you actually begin to, you deploy and begin to use the device.
So that's the, let's say, the cloud platform that you are using to send the data to, or something like that.
Yeah, it doesn't matter where things are where the data ends up flowing, but it is wherever it's headed. You can add in some identity here that is trusted by that platform or provided by that platform. And so as you go through the process, everyone involved gets to add their information and have it become part of the chain, part of this stack. And you have in the very middle here in the orange this this customer Ldf Id. The idea is that you would like to probably track information business-wise as you step away from raw manufacturing and into something like final assembly or packaging and preparation for a customer deploy. And the larger your single customer, the more likely it is that this part of the process is going to be important to you. What I mean by that is, if you're deploying 10 or 20 devices and you need to assign a customer ID to those, it might be acceptable to drop that identifier into some software system somewhere and just tag it, right? This is similar to what you would do is, you know, oh, you want to give me your email and I will sign you up for my web app because each of you is unique and that's how you identify yourselves. Imagine now that you have a customer that needs to purchase 200,000 units from you. Chances are pretty good that at 200,000 units, you're going to start to make mistakes. You're going to misallocate some units. You're going to lose track. You're going to miss some of them. And so here's where automation and process and some form of checks and balances are really, really helpful. In other words, successful business at scale is where you start to really care about this. And you can't apply these things to a structure that doesn't have the foundation. It's just, there's no way to go backwards and say, I built this thing, I built it from a maker board, and I decided to build, 100,000 of them. And then now I wish I could add some trust in the root identity and stuff. Go ahead and ship them all back to me and we'll go ahead and open them all up and put it in there. So you think about this stuff ahead of time because you know that you're going to reach scale.
Yes, and maybe some people in the audience will think, well, I'm not a device maker, so this is of no interest to me. But in fact, the customer at the end can be your own internal customer, maybe yes. A business unit you are delivering this to, or your actual end customer as an organization that delivers services. So when we look at this, it applies to nearly everyone in the industry, literally, not just device makers or software providers or people like that.
That's right. And, there's a principle to distributing like the best thinking around security, which is the same as the way that you can distribute the best thinking around privacy and stuff, which is to bring it home in a way that also illustrates the material impact, not just to quality of human life and protection of data, but also the bottom line in terms of finances. And this is because sometimes we look at something like this and say, it seems like there's a lot of work involved. Could it be that our first product that we released just doesn't have these things because we didn't have time or we didn't have budget, and it would have been right, but we thought, well, we've got a business to run. Let's bring it all down to, the impact that it will have going forward. Yes, it's true that all of this stuff will help you avoid the negative consequences of a security breach and so on. But this is similar to telling people you have to roll your passwords over regularly and you should have a different password for every website and so on. A lot of folks take heed, but a lot of folks also do not, because they're kind of saying, well, it may or may not happen to me. I would like to tie this to a greater financial impact that is hopefully going to be attractive to everyone who's listening to this. The process of getting these devices out the door is incredibly expensive when you need to assign the identifiers to the customers manually, and when you need to set up the orchestration and the automation using some kind of a service-driven process. Let's say, for example, that you have those 200,000 units being purchased by one of your customers. Those units need to be set up across, let's say, 400 different work sites. So that's a fairly large number of units per site, but it's also a fairly large number of sites. If you do not have this infrastructure in place, which is a good idea for protecting, data flow and all of that for the future, if you do not have this structure in place, you won't be able to reach what we call zero-touch onboarding. And zero-touch onboarding is going to save you, let's say that you have an on-site technician that is contracted for each of the 400 locations, and they are $200 per hour US. And those 400 locations require travel because they are not 400 locations all within a regional geography. So the travel includes flying and shipping equipment and all of this stuff. If you look at all of that, your incentive as a business should be to minimize the number of hours, or if possible, completely eliminate the need to deploy a technician to those 400 locations. If you put in place the infrastructure that we're describing here, you can possibly eliminate the need to deploy anyone and simply ship the devices and have the customer install them and set them up themselves. If you do not have the infrastructure that we're showing here, chances are pretty good that you're going to bear a significant cost for every deployment location. So as you think about your scale, it's not just being concerned about the potential future negative consequences of not having great security in place. This is how you can actually reach scale that does not break the bank. And the amount that you would spend per customer in the deploy means that so many months of edge compute solution subscription that you need to charge before you even enter into positive revenue. You won't even get out of the red if you have an expensive install for quite some time. So this should be appealing to even those who say security is great, but can we afford it, or can we spend the time on it? I don't think you can afford not to. I think it's going to be a huge bump in revenue. So if that's the infrastructure that gives you that ability to do zero-touch onboarding and save all of that money and be in the black sooner, and it's the right thing to do from a data attestation perspective, which requires a device attestation, then everything should be aligned here, which is an important thing to note, because if you're watching this and you're saying this is what we should be doing, but I'm going to have to convince someone to open their checkbook to do the implementation, here's the incentive right there. And it means that if you're buying devices that you're going to use and you're buying them from another party and you're going to use them in your solution, you should be thinking about what the deployment and onboarding experience is like. And you should be asking your supplier of the device then, do they comply with this infrastructure and this paradigm? And if they do, how can you then leverage this to make your onboarding automated and your attestation hit high scale?
Yeah, and this is especially important when you consider what we are about to write in our fourth posts, in the sense that that fourth post, yes, will synthesize a bit what we discussed, and at the same time will open the door, or rather enumerate many of the possibilities you will have once you establish this fundamental root of trust in your infrastructure. So obviously we are teasing people there, but what can some of those things could be?
Yeah, so there's some really interesting ones that come up particular to edge computing. Perhaps I'm going to use a bit of scouting software on the edge device to detect whether anything interesting has shown up on the network that I could utilize, or that has been plugged into the any of the available ports on the board. Here's a really good example. I am an edge compute node, and I'm doing some edge AI, and I notice all of a sudden that an authorized LiDAR camera has been plugged into the board. You would think that you would want to make that edge compute node eligible for a new set of applications because it has this piece of hardware. in the Eclipse IoFog world, we call that an edge resource. This is something that you can utilize in the camera or some storage or an AI accelerator chip. And these are things that you would like to detect. Well, if you can trust the underlying hardware, then you can trust that the thing that's been plugged into it is probably being detected properly. And then when you deploy the application to that unit that has the LiDAR camera attached, you know that it's probably really a LiDAR camera and this is not all being spoofed. And therefore, it's okay to deploy your really cool AI code that runs against the point cloud coming from the LiDAR camera, because you know that it's actually running on a device that somebody doesn't have tap wires into and isn't, basically grabbing all of your code or your keys or your neural net model. So that's really cool. And you could call this kind of like, really it reaches a level of like application attestation. It becomes possible. I know that I'm running the apps at the edge that I think I'm running. And so therefore, when I report data to my AWS cloud or my Google cloud, to GCP or to my Azure cloud or wherever you're putting it, you know that the credentials to pass the data to the cloud have not been stolen, compromised, and that the data that you're getting is not spoofed. And so all of this is just built all upon that stack. But edge application attestation is a fascinating area. And then all of the state of the edge board and the devices attached to it can then be attested as well. And so think about being able to trust how much RAM is available before you deploy an edge microservice or an edge application. This is a state of the edge node, and you want to know that you can trust that as well. And so location is another piece of state information that's very interesting. You might even have something like an orientation in 3D space of a robot that's navigating a warehouse, and being able to trust its the direction in which it's pointing would allow you to do things like turn on a live video feed, because this robot is patrolling the warehouse, and you're not allowed to monitor the employees outside of the designated zone. So you can't just drive a robot around and point at the break room or the bathroom or the employee vehicle lot. So you turn off the camera when it's pointing in an area that's protected. All of this stuff lays the foundation for us to build the world that we want and avoid the dystopian society that we're scared of, because these levels of trust allow then the good actors to implement things that that we can agree upon and know that what we've agreed upon is actually enforced. And because it'll all break down, of course, if you can't actually trust that information flow.
Yeah, this is really fascinating, and we will at least very briefly mention some of those possibilities in the fourth post, but I think we'll have a number of follow-ups to really dig on more specific applications in the future as well. Now, we are nearly at time, and you alluded to something in what you said, Kilton. You mentioned that a specific concept was implemented in Eclipse IoFog as a resource. Mm-hmm. Now, that's one thing I should have mentioned when we started the broadcast. I didn't even introduce you. So Kilton, you are the CTO at Edgeworx, and you are also the project lead for Eclipse IoFog, which is one of the great edge computing platforms we have in the Edge Native Working Group. Now you have a release that's coming soon, IoFog 3.0, that has a number of new features that are of interest for device attestation and other edge computing domains, more generally speaking. So maybe as a closing statement, we can briefly cover what will be in that exciting release.
Sure. Yeah. IoFog 3 is coming out, and you can use the beta today. At this point, the beta is so well baked that it's super trustworthy and is in use in some production systems already. If you are using the beta, the roll to the official release should be essentially zero change. So it's not that you'll need to do an upgrade to get anything different, just rather that the beta becomes the last fully tested beta becomes the production, which is how it should be. With related to what we're talking about here, this concept of edge resources is new to IoFog 3 and is is a great way to begin to get information about what's happening at the edge that you can use to deploy the right edge microservices and therefore the right whole edge applications. By the way, edge applications are composed of a number of microservices, and so you can deploy with Eclipse IoFog, you can deploy an edge application across a number of edge devices, making microservices go wherever they need to go in order to form the full application. So imagine that a microservice requires a camera. You would want to know that that camera resource is actually available on an edge node or on a device before you deploy the microservice that's going to use the camera. And in fact, you might want to know which edge node is the one with the camera so that you can properly orchestrate that microservice to that one. And maybe the microservice that does the AI computation goes to a different node, one that has an AI accelerator chip in it. All of these things outside of the core CPU, RAM, and disk can be described as edge resources. And now the mechanism for discovering them is still being built out and is available plug-in style, meaning that you can do any variety of methods of discovery. Maybe I'm going to scan the network and look for an IP camera. Maybe I'm going to just check out the devices available on USB connections. These are all possibilities. The structure for turning that information into a listed resource is there in IoFog 3 and makes its way all the way up through to the control plane, into the what's called the controller in IoFog terminology, and then can be used for decision-making, display, and state checking, and also can be used for orchestration and reporting and all this great stuff. And so that's a really good reason to upgrade to IoFog 3 if you're using version 2, is you get that capability. Also in the release is a whole host of improvements, but one that's also worth mentioning in this discussion, in which we've talked a lot about large-scale deployment, is the considerations that you have when deploying across a variety of locations on a global scale. One of the concerns you have is making sure that the settings for those edge microservices are applied to the local geography. And the most common configuration item that gets missed is adjusting for the date and time of the microservice. And so because we often have solutions where we want to report data from each location in the local date and time so that we can have an understanding of when it occurred and we don't want to have to do translation, we often have microservice settings such as, what's my local time zone? Well, if you go and you move something around, you're going to have to remember to change it. So if a customer has it at one site and they move it to another site, you need to know this and you need to change, or you need to teach them how to change the configuration. One of the convenient things added into IoFog 3 is the ability to pass the local time zone information from the operating system, which will update as you move locations, pass that into the microservice as a dynamic config item that you don't have to remember to change. And this is like a really fine point on the release that I'm discussing, but it directly applies to the stuff that we're talking about, which is you are going to deploy at a much larger scale. How do you make sure that things don't begin to break down and you have human error introduced into the system? Well, that means as many things as possible should be process driven and automated. And this is yet another thing that was added to help with these types of issues.
And to me, that one, yeah, you said it seems tiny, but when you worked a bit in the domain, the alternative would be to put everything in UTC and then all of this translation logic all over the place, and that's a real mess. And
Yep.
in mobility applications, let's say I have this edge node on a locomotive, crossing the Great Plains and changing time zones. The fact that the infrastructure itself really is taking care of things is really where we are headed as a working group. I see this tiny feature as a kind of incarnation of our EdgeOps vision, where essentially it's about simplifying the lives of developers in having the platform perform the grunt work of those tiny details that are yet so important in the edge environment.
Absolutely. It really all comes down to enabling developers and then enabling operators. And if these things are in place, then the next killer app of edge computing, I would say computer vision is the first killer app of edge computing, real-time computer vision. The next killer app that gets created, it rests on this infrastructure. And imagine if the Angry Birds game on iPhone or on mobile phones, right? Imagine if the infrastructure to handle 1 million downloads didn't exist. Then the popularity would have never risen beyond a small level. In order to reach the level that we're expecting for edge and IoT solutions, we need to have this infrastructure already in place. And this is, if you can't operate it, develop it for scale and operate it at scale, then you're not planning for success. You're planning for limitations, which is, a business failure relative to what you could have had. So it's all about smoothing the way for developers and operators. Yeah.
Indeed, and at the same time, it's a great example, and at the same time, it's a bit dated, I think. Angry Birds.
My example, yeah, that's true. Well, I'm not the youngest person.
Yeah. Well, I'm not either. So we're just showing up our age there. But then it just means you were a pioneer, as a mobile user. So to me, it's a great thing.
That's right. That's right. It's it's one of those success stories that I think every single person in the world was jealous of the success of that.
Indeed.
That game overnight. Yeah.
Excellent. So, Kilton, that's all the time we have. Thank you so much for this conversation. I hope in the audience you enjoyed it. Really, people can look forward IO Factory, future posts on the Edge of Things, and we will be announcing at some point interesting things about our Edge of Things publication on medium.com. I think our intent is to make this open not just to Eclipse contributors, but eventually to others. So stay tuned for details like that. We'll also have an upcoming episode in the Edge of Things, which we will be calling, so to speak, Zeno Summit. So stay tuned for that as well. But essentially, we have the Zeno community that wanted to showcase some use cases and things like that. And so we will be broadcasting or doing an extended broadcast in order to showcase that. And there will be other episodes throughout the rest of the year as well. So please stay tuned to get the details about those. So Kilton, you're the CTO at Edgeworx, the project lead for Eclipse IO Fog. Thank you so much for sharing this conversation with me today. And I'm Frederic Desbiens. I manage programs for IoT and Edge computing at the Eclipse Foundation. It was a pleasure to have you in the audience. So thank you again for watching, and see you next time.
Cool. Thanks.